We ready, Carl? Excellent. Okay, so our previous speaker was the one who came the furthest to this conference. Our next speaker, I believe, is our first person in the history of North Bay Python who actually lives in Petaluma giving a talk. Everyone, please welcome Sarah, who's going to talk about OpenTelemetry.
Hello. Yes, I live over the river and over the hill, so you can kind of wave that way and see my house. So I'm Sarah Hudspeth. I'm a solutions architect at Chronosphere, and I'm super excited to talk to you today about observability for you and me with OpenTelemetry. So quick poll. You can just raise your hand on a scale from 1 to 5. How comfortable are you with observability and OpenTelemetry? 5 is like, I've dug into Otel libraries, I've instrumented a collector. 1 is like, I've heard of observability, Ollie, is there a connection? Are they the same thing? So I saw a 2, I see a 1. Okay, all right, we get some 3s, some 4s. All right, so this is just gonna be a broad overview of kind of the OpenTelemetry observability community, and my goal is really just for you to want to take one step further into these communities and learn as much as you can. All right, let's see if I am on the right screen so I can, no? All right, I should know how to do this. No? Here we go. Okay, so what is observability? The best way to frame it, in my opinion, is you can build the coolest app. It has awesome stuff happening, but if you don't have a check engine light or a fuel gauge to tell you when resources run out or when things go sideways, no one else can experience the awesomeness of your app. So observability is kind of the umbrella term for all the tools we use to kind of create signals that tell you how your applications are working over whatever potentially distributed and cloud-native systems you have. Telemetry, which you might be like, oh, here's another vocab word. Telemetry is what we just say is the automated way we collect and organize all of this data, right, from remote sources, and we transmit it back to a central location so that we can eventually take action on it. So this is your visualizations and maybe creating alerts in some ways to notify you of what's happening in your system. So here's an example. This is actually the OpenTelemetry demo microservices app that you can go play with if you're interested in. And as you can see, right, there's a lot of things happening, right? We have a lot of calls. The surface area from which we have to collect information and organize and management is vast. And, you know, sadly, Python is mixed in there. It's today kind of with containerized applications, right? You can build in whatever language you want and piece them all together. And that's getting into kind of the challenge of telemetry, right? How do we build systems that can collect all this data and manage it, process it? I should mention that there are 3 major types of telemetry, right? You might have heard of metrics, you might have heard of logs. Tracing is also really big these days, just because it's giving you a lot of context and a lot of information. And if you've heard of distributed tracing, right, that means we can go in distributed systems and follow the path a request takes no matter what we're calling or where we're going. So a further definition, right? So a trace is one of these telemetry pieces of data that we're going to collect, right? It gives you the big picture and understanding the full path of a request takes, right? Something happens and something else happens, right, until the things stop happening. And the spans represent the individual units of work and operations and kind of build up the traces. And it's really nice, right? If you can get what's happening in your system in a nice waterfall view, right? You can see the client was called and it called another API and there were some async calls and lots of things happening. We have a nice visualization, and when we add numbers, right? When we add durations of these spans or number of calls, or if there was an error, right? We're getting a lot of information about what's going on in our system that we can either react to or, you know, you can see that there's a call for multiple polls. If we see that 1,000 times, maybe we're like, oh, this looks like an inefficient database call. Maybe I should go optimize my code, right? So there's a lot of things you can do once you have this data. And this is just another slide that gets in, right, how we kind of create spans and traces. We start something, we add context, right, and we can kind of map it across time so we know what's going on. And I would say the other thing to kind of add into here is, this is kind of, if you've heard of like 95th percentile, this is kind of the theory that you like look at the worst behavior of your application, so what are the top 5% worst experiences your users are having, and just kind of building out decisions after that to make your awesome app even more awesome. So, right, this is the goal of observability, right? To be able to know what's going on in your system, be able to triage any issues, and then understand what's the next right thing to do in order to have the most awesome app. Super easy, right? I think we've heard other talks that kind of build up and tell you, no, actually, it's not kind of easy. So I'm going to throw another vocab word that you might have heard, and that's cardinality. And let me just quickly explain it. So, you know, we're moving these days from monolith applications, right, that kind of have this set path and maybe a little bit static, where, you know, we collected the telemetry data and maybe we got 150,000 possible unique time series, which is completely manageable to analyze somewhat. But now that we're in a cloud-native environment and then we have distributed system, we have containerized apps that are kind of part of this huge ecosystem, the surface area of which we have to collect and manage data has just grown exponentially. And right, that's the cardinality, right? We were talking about math during lunch, right? Cardinality and unique objects in a set, right? Now we have 150 million possible unique time series, and that's a lot of data to manage. And that's a lot of surface area to cover. If you're trying to dig in and find an issue, like, where do you start digging in, right? You can be overwhelmed by the data. And that's kind of why we kind of want to watch cardinality of our telemetry data, right? We don't want to be overwhelmed with data. But let's be honest, we are. We are overwhelmed with data in life. And the last kind of issue we have, which I'm not going to spend too much time because OpenTelemetry actually does not store data. It will just let you send it somewhere of your choice to store have storage, but retention's another issue. Like, once we have this data, how are we going to store it? How long are we going to keep it? Do we need it for GDPR compliance, right? That's a big other issue that folks in the observability space have to solve, because you want to use your data. You just don't want to put it in a box and on the shelf. So you want to be really smart about the data, how you collect it, how you store it, and you want to be efficient so that you're not spending lots and lots of money. And this is why I present open source observability to you all, because it's going to give you a lot of freedom when you use open source tools in the observability space, because you're not going to be locked into one particular philosophy of observability. Like, if you just choose like a vendor and have to pay them money, they kind of determine your philosophy. So open source, it's vendor agnostic, right? You can pick and choose, you can see what works for you, and it gives you a lot of control, and you're able to kind of pick and choose how you're going to organize and store and process the data. And before I keep going into OpenTelemetry, I do want to step back and kind of give you guys a history of the OpenTelemetry project. So distributed tracing kind of hit the industry in 2010 when Google published a paper on Dapper, and that's kind of when distributed tracing became a thing. And then 5 years later, Jaeger and OpenTracing came out as well. OpenTracing was the third cloud-native Cloud Foundation hosted project. The first was Kubernetes, the second was Prometheus, but the third was OpenTracing. And at the same time, Uber open source Jaeger, and Jaeger is a tracing UI, so that's actually like a visualization. And I'll show you a picture of the UI in a bit. And then in 2017, OpenCensus released a set of libraries that allowed you to collect application metrics and distributed traces. And application metrics, you know, are like duration of web requests, error rate, throughput, how many folks are hitting different calls, and we've mentioned distributed traces. So this just allowed you to collect the data, but then again, you had to send the data somewhere else for it to be analyzed. And then a miracle happened in 2019. Folks decided that they were stronger together, and so OpenCensus and OpenTracing combined forces and decided to put all their efforts to have a well-integrated and surface of end-to-end distributed tracing and telemetry. And that's kind of where we are right now in the OpenTelemetry project. And again, this is an open source project. People have been devoting blood, sweat, tears, and happiness to make all of this happen. And there is a broad call for you all to join in the fun. There's still a ton of open projects to be done. And That's kind of where I am right now. Go to OpenTelemetry.io. Go learn about the Otel Collector. Here I have some visualizations of kind of what the Otel Collector can do, and you can kind of start seeing these different telemetry data types and how we bring them all together and how we can send them elsewhere. I'm going to do a really quick deep dive. I know there's a lot of documentation out there, so please go and take a look at what's out there. But basically, the idea between OpenTelemetry and Python and there's a lot of languages, and Python is actually super well supported, is auto-instrumentation, right? So you basically pip install the OpenTelemetry collector, and it's going to go fix your code, grab kind of all the metrics, create all the function it needs to grab the data. It might require some use of the Otel API or SDK, depending on how complicated your applications are. And it'll put it in a nice data format called OTLP, right? So that's the OpenTelemetry protocol, and that's the data format the Otel Collector accepts. So it'll send all your data to the Otel Collector. And there are lots of libraries that already have all this auto-instrumentation, right? You are not touching your own code. You just instrument it. There are manual processes where you will touch your own code and kind of create the wrapper functions you need to kind of grab all the data. But Python, again, is well supported. So there's a ton of stuff, so you can get information about your database calls and see if there's any ones that are taking too long and where you can optimize. And once the telemetry data is kind of formatted, it's sent to something called the Otel Collector. And this is where three things happen, right? It receives the data. So if we had those distributed traces that were all over applications, it would kind of compile them all together. The processor is what's going to allow you to really control your data. I'm going to throw out sampling. Hopefully that's not a scary subject, but you have the ability to either write rules to create samples or just randomly select data so that you're not sending everything and overwhelming yourself, right? You're being smart about the data you choose to analyze. And then it has an exporter, which will change the data into whatever format you need and send it to your observability backend of choice. And I did list some backends. So the open source backend for metrics is Prometheus, Jaeger's for tracing, and then FluentBit is one of the ones for logging. So if you're interested in continuing to open source, you can send it to open source. If you're interested in sending it into a vendor, like Chronosphere or any of the other ones, New Relic has like 100 gigabytes free if you just want to go play around and see what theirs looks like. You can go find out if there are some vendors that have free tiers. But yeah, you would send your data there, and that's where you kind of would do your visualization. And this is an example of kind of this waterfall trace from Jaeger, right? We see a lot of information on the left, right? We see a call being made to a recommendations service, something happens there, we go to the feature flag. And this just gives you a lot of power, right? If you have customers calling me like, I can't access this web page, you can go here and kind of figure out, oh, there's this thing that's blocking this, let me fix that, and you can get out ahead of any issues. And if you're making money with your application, you want to keep making money, so it's really nice when you can go and solve problems quickly. This one is just going and is a more in-depth kind of visualization of the collector. And T stands for traces and metrics, and then L for logs, so you can kind of see how the collector is combining all these different data types and kind of organizing them and sending them to different backends. And then at the bottom, these are actually metrics about the Otel Collector itself. So the Otel Collector will also monitor itself and let you know when it's running out of resources or potentially a cause of data disappearing or what have you. And again, this is all from the OpenTelemetry docs. Things are really well supported and outlined, so go take a look. And if you are interested or if you're overwhelmed or you're like, oh, this is cool, I want to help, they have something called special interest groups, and there's a lot there. So you can go be a lurker or you can go ask questions. They have Slack channels. You can go look at the notes from their meetings. They have meetings every week. Python, I think, is at 9 o'clock Pacific time on Thursdays, right? They really welcome contributors and people interested in asking questions. I have another plug for the Slack channel, like the Cloud Native Cloud Foundation has a Slack channel that everyone's welcome to join, and you can go and join the channels you're interested in Otel or Otel Python. They really do welcome people's participation, right? There's a lot of work to do. The project has really grown recently, and they need all hands that they can get. And but also you can just go and see what's happening and seeing what kind of questions are being asked, what kind of problems are being solved. And there is a KubeCon in Chicago in November, so if you want to go meet people face-to-face, there are folks there. And I keep saying it's well supported, and what I mean by that is there's 145 organizations that are sending folks time, resources, people are building out integrations on the company's dime to really make sure this project thrives, and people believe and know the vision of telemetry for everybody and observability for everybody with really high standards that works well. I'm wrapping up soon, but I did want to throw out that if you are interested and you want to kind of kick the tires and see what I'm talking about, Paige, my colleague, she couldn't make it today, but she did help with the presentation. She has a telemetry course for you where you can go and you can run up a Flask server and you can pick and choose your own adventure with auto-instrumentation or manual instrumentation. So go ahead, take a picture. There's a link down there so you can go and do your own OpenTelemetry Workshop. There's a lot there. There's 5 different labs. Feel free to just do one. And that's it. And if you have questions, please reach out to me and Paige. We're totally open to answering questions or pointing you in the right direction. Paige has a website that has a lot of other resources. And I hope that observability with OpenTelemetry is for you as much as it is for me. And thanks.
Thanks, Sarah. That was great.